lesson we talked about the GCF. And remember I said the first step of factoring is take out the GCF. So the first step of factoring is the GCF. Okay? Okay. So it is the first step of factoring. Now we're going to talk about factoring. All right? But before you factor, it's always best to take out GCF because it will make the number smaller and it's easier to do this part, the guess and check. All right? So here we go. All right, so we're going to practice this skill down here. We're going to find two numbers that multiply to equal the first number. And add or subtract to equal the second number. So, two numbers that multiply to give you 24, okay, that add up to 11. Okay, so what are some numbers that make 24? 12 times, not 14.
Oh, so I gotta add.
Multiply for this, add to this. Yes. Next stage. What two numbers multiply to give you 24 that add to 11? 1 and 24, 2 and 12, 3 and 8, 4 and 6, 3 and 8. I guess I really could have listed all these down here. Whoa, hello. There you go. And done that. Okay. Let's see about all the numbers that multiply to give us 72. All right. 1 and 72. Don't worry about the negative right now. 2 and 36. 3 and 24. Right? Yeah. Okay. 4 and 18. 6 and 12. Okay. Since we have negative numbers, okay, we want one of the numbers to be negative. And they have to differ by 14. Which one? 4 and 18. Right? And which one do we want to be negative? We want negative 14. There you go. So, 8 times 3 is 24. 8 plus 3 is 11. 4 times 18 is negative 18 is 72, and 4 plus negative 18 is negative 14. That's the skill you're looking for. You're looking for two numbers that multiply to give you one, add or subtract the other. Now, quadratic expressions, we talked about this before, look like this. Ax squared plus bx plus c. Two-factor means to write as a multiplication problem. That's healthy problem. Not the other one. Write as a multiplication problem. And think about it. Back when you were in grade school, and you did a factor tree, right? And you said, oh, 18, how does it break down? Oh, 2 and 9. Well, what's happened there? 2 times 9, and 3 times 3. You're factoring it, you're breaking it down into multiples, things that multiply to give you that number above it. That's all factoring is here, it's just more complicated than it was in grade school. Right? So, for example, x squared plus 5x plus 4 breaks down to x plus 4, x plus 1. We talked about this before with multiplying binomials. FOIL, right? First, outer, inner, left. So x times x, x squared. The outer and the inner, 4x plus 1x, give us that. And 4 times 1 gives us that. So it's just like the circle of life, okay? You multiply, you FOIL to get a quadratic, and you factor to get the binomials. You multiply to get the quadratic, you factor to get the binomials. You factor, multiply to get the quadratic, you factor, divide to get the binomials. So just going in a big circle. Multiply, and divide, multiply. You multiply to get the quadratic, you divide to get, you factor to get the binomials. And it's just a circular relationship. Just like with the factor tree, 18 divides down, and if you want to get back to 18, what do? 3 times 3 times 2. You multiply to get back up. And it's just a circle. Okay. X squared plus 3x plus 2. Okay, so x squared factors, oh, I know, it just factors into x times x, which looks kind of funny. Let's change this to a big old dot, because really we don't use x for multiplication anymore, so let's change that to a big old dot. X times x. We put an x at the beginning of each parentheses, right there. It's just the first step, we just put an x there. Now, we do what we just did. We're going to find the two numbers with a product of 2 that add up to 3. Well, that's obviously, there's only one way to get 2. 2 times 1. And 2 plus 1 make 3. Yay, we're done. And then, we think this is it, but remember, this is called guess and check. It's not guess and hope. It's not guess and pray, and just move on and hope you did it right. It's guess and check. So if you think you got it really quickly, it does not take long to FOIL it. X squared, 1x plus 2x is 3x. Yay, 2. Oh, that's what I started off with. It does not take long to check. Why move on to the next problem when it takes 10 seconds to check? Okay, so let's do some more examples. Let's try to practice this out. Well, this is pretty weird. Okay, so just start by making 2 sets of parentheses. All right? These are all x squared. Okay, this first lesson is all x squared. So it's always going to be x times x. First off, right off the bat, it's always x times x. Now, we're looking for 2 numbers that multiply to give you this, that add to this. That plus, being that it's positive, tells you you're going to add up to 8. 5 and 3, very good. So 5 times 3. And they're both going to be positive. No, I just said it multiplies to this, adds to this. It multiplies to the last number, adds to the middle number. And again, don't move on. Let's just check it real quick. X times x, x squared. 3x plus 5x is 8x. 15, we're good. How long did that take? 7 seconds? Just check it. Why not make sure you got a perfect score before you turn in your test? Okay, this one's a little bit different. They're both going to start with x. Now we're looking for 2 numbers that multiply to 6, but add up to negative 5. Negative 3 and negative 2. Because remember, a negative times a negative is a positive. But since the middle number is negative, they both got to be negative. Okay? If this is a positive, that basically means both are going to have the same sign. Because the only way to get a positive is 2 negatives multiplied and 2 positives multiplied. Only way. And again, real quick, x squared, negative 2, negative 3 is negative 5. That makes positive 6. Yes. All right. X squared plus 7x, minus 18. Okay? Now remember, what that means is this time, one of the numbers is going to be positive, and one of the numbers is going to be negative. So technically, back to the beginning notes, technically, if they add up, because you're adding a positive and a negative number, but some people like to think of it as subtract. So that's why I talk about both ways. So they're going to differ. They're going to differ by this amount. And since it's a positive number, we want more positives than negatives. So what two numbers multiply to give you 18 that differ by 7? 9 and 2. Very good. So since this is positive, I want more positives and fewer negatives. And here, especially when that last number is negative, here's where guess and check is very important. Because often people will put the signs wrong, and then you're wrong. So guess and check on these, important, but not majorly. You're probably not going to screw that up. But if there's a negative in there, in the last, right here, if there's a negative, oh please, check before you move on. And here's how easy it is. X squared, obviously. Minus 2 plus 9 plus 7. Oh, I'm good to go. Negative 18. The most common mistakes with factoring when the last number is negative is boom, x minus 9x plus 2. See it all the time, even in algebra 2. So please check. This one's a little bit different because this time we have negatives left over. We want more negatives than positives. X, x. Now I need two numbers that multiply to give me 48. And this is where you might need to take out a calculator and actually do some real quick. 48 divided by 2, divided by 3, divided by 4, divided by 5. And find two numbers that multiply to give me 48 that differ by 2. So they're going to be really close together. 6 and 8. Now, since I want negative 2 left over, which number should be negative? The 8. And this should be positive. But we're not going to move on. We're going to check. X squared, obviously good. Minus 8 plus 6 is negative 2. Good to go. Negative 48 for sure. Okay? I think we've done enough. Everybody got a good grab on this? Does it make sense? Any more examples? Everybody solid on it? Okay. It's the same thing over and over. Now, here's where the previous lesson is very important. We're going to learn how to factor something with a 2 here, or a 3 here, or a 4 here. We will learn in the next lesson how to do that, because you have to. And if this number here was 31, or 39, or 57, we would have to factor it the way we're going to learn later. But here's the beauty of it. 2, 16, and 30 are all divisible by 2. So if we divide by 2, if we take that 2 out, okay, like we learned yesterday. Now remember I talked about yesterday in the previous lesson, don't just do this because people throw away the 2. That's a very dangerous thing. Because that 2 has to stay here when you factor. We'll talk about that at the end here. Why that's so important. Okay, so we got to put that 2 there. And now we're going to factor, divide. 2 divided by 2 is 1, x squared, which brings us back to what we've just been doing. 16 divided by 2 is 8, x tags along, and this is 15. Now we do what we just did. Okay, very easy. We're going to find two numbers that multiply to give me 15 that add up to 8. I think we already did it. It was 5 and 3, right? And they're both positive. Here's what happens. This is what people put. If they do this thing, where they divide by 2, divide by 2, divide by 2, then what they do is they write this. When they divide by 2 like this, they just write this, and then they write this. And that's wrong, because we're going to guess and check, aren't we? So, x times x is x squared. That's what we started with, right? Oh, no, it's not. If you throw away that 2, you don't have it completely factored. You threw away the 2. That 2 has to be stuck outside. Now think about it when we guess and check. Watch. X times x is x squared times 2, bingo. 3x plus 5x is 8x, times 2 is 16. Good. 5 times 3 is 15, times 2 is 30. Oh, okay. There's what we needed. One of the most common mistakes I see here, even in Algebra 2, is people doing that division thing, losing the 2, and they get down. And they did factor it correctly. You are right. You factored it right. But this right here is not equal to this unless you have this stuck on. So it's not right. You factored right, but you lost something. So please, please, make sure when you factor, like we're going to do right here, these are all divisible by 3. So we're going to put the 3 outside the parentheses, and we're going to divide this way. This is how we will divide. 3 divided by 3 is 1. Remember, you don't have to put that 1 there. Just a good habit. Negative 24 divided by 3 is negative 8x. 45 divided by 3 is 15. Now I do what we just were talking about. I write the 3. Now I write my 2 parentheses. I put my x and I put my x. Now remember, on this one, I need 2 numbers that multiply to give me 15 that add up to 8. Well, we already have that, right? It's the same thing almost. The only difference is, in this one, I have a negative 8. So these both have to be negative. You're going to see a pattern here. Pardon me? That's W3. Now, we check. X times x is x squared times 3. Boom. Negative 3x, negative 5x is negative 8x times 3. Boom. Negative 5 times negative 3 is positive 15 times 3, 45. We're good to go. Okay, last. These are all divisible by 4. I'm going to write my 4. And I'm going to put a big parentheses. I'm just going to divide. 4 divided by 4 is 1. I think you're going to see where we're going here. 4 divided by 4 is 1 again, but it's a negative 1. And then, oops, big number. Not really. 12 divided by 4 is 3. Tack on the 0. Alright? So here, we want 2 numbers that multiply to give me 30 that differ by 1. Very good. 6 and 5. So I put an x here, I put an x here, I put a 6 here, I put a 5 here. If you put 5 and 6, it makes no difference. But what's important is, what do we want more of? Positives or negatives?
No, negative.
Negative. See this number right there? So we want the 6 negative and that positive. And quickly, we're going to check. X times x is x squared, but times 4 gives me that. 5x minus 6x is negative 1x. Times 4 is negative 4x. Negative 6 times 5 is negative 30. Times 4 is negative 120.